a little bit about the Lil'Slugger project, which is a little 12-inch bat. The way this is the finished part right here, and the way we get to that is first operation is turning this diameter in the bat end and engraving it all in one operation. That way, if you take the part out, the letters won't be out of round with the bat end. So you'll need a C-axis lathe to do this with. So ideally, the second operation, you would turn the handle end using this part to chuck onto. So there should be plenty of material between the handle end and the bat end to chuck onto, which will eventually turn out to be the angle. So if these two parts are made right, the angle will wind up being correct as well. So for now, we'll just talk about how to get started with this first operation here, which is cutting the back end and doing the engraving. So ideally, again, you'll wind up with this. This is a picture of the very last operation. We want to leave a half of an inch extra on this end for the center drill mark, so that when you're turning the taper, this taper on the bat between the two operations, you'll have a extra material to face off last thing with this fixture. So anyway, I'm going to send you a Mastercam file, and when you get the Mastercam file, you'll see something like this. And if you want to get rid of all these tool path marks here, just press Alt and T at the same time, and that'll make those disappear. So what I want to do is I want to just turn on the turn profile. So if it's not on the levels screen, just come down to this little tab down here, click on levels, and then you can select up here, you can select turn profile, and then make this your active level, and then deselect the bat. Okay. Now if I right click, this will allow me to look at the top view, and I'm just going to go ahead and give you the program on this one, because I actually used Mastercam to find the points on this radius right here, because it was going to be way too much trouble to trig that out in class. But I will go over the finer points of the program. So if I move my mouse over to here, down to tool paths in the lower left hand corner, click on that and come up here to lathe finish and select that folder. Okay, and then I come up here and select back plot. It's going to show the operation when I press the start key up here. So this would be a DNMG, which is a 55-degree diamond. And basically it's just going to come up, and I believe I actually just have it turning this radius. So I just used Mastercam to tell me what the points were, particularly not so much on this tool, but on the back tool, because again, this geometry looks pretty simple, but it's actually kind of complex, because it's a radius going into an angle. And it's just not within the scope of the class to sit around and trig all that stuff out. So the second tool op would be a left hand OD. You see this 55-degree left. So if I check this folder and I press the backplot key again, it's going to show the tool path for the left hand. Notice it's pointing the other way. That means it's left-handed. So I know we have plenty of left and right-handed tools around the shop there. But it's going to just cut that little radius and off it goes. Okay? So let's just go ahead and look at the program. I'm going to send you the drawing, the Mastercam file, and also program. And that should get you to where you can get the bat end turned. I know there's 2.5 inch. There's a big bar, a 2.5 inch round in the stock room, and so just get you a piece and saw you a piece of 12.5 inch long. So like the extra half inch, that extra half inch is going to end up being on this back end for a center drill. Okay, and we'll face it off last thing. So when you set this up in the lathe, you want to set it up just to take about 30 thousandths off the front here, and then that way you'll have plenty of extra material on the back. So when we get to doing the handle part, we have to actually measure the length so we know how much to take off of here to make it right. So let's talk about the program. Since you're looking at this on your computer, I'm just going to highlight each line and kind of have a review of what each G code and number does. Okay, so G0, that's rapid traverse. G97, that is constant surface feet off. So G96 and G97, G96 turns constant surface feet on, G97 turns it off. That means as the tool is getting smaller, the RPM is going to kick up. That's when your constant surface feet is on. G99 means inches per rev, so your feed rates will look like this down here, more like the f.004, as opposed to like 4 inches per minute. So that's inches per rev. G97 or G99. G28 means the machine is at home. So if the machine wasn't, if X and Z were not at machine home, when it reads G28 here, it will take it home. G80, so this is kind of your safe start line. G80 is going to cancel out all your any kind of can cycles you have going. Like like drilling cycles or anything like that would be canceled out with G80. G18, remember, is ZX plane. So G17 is XY, G18 is ZX, and G19 would be YZ. So this is usually for cutting circles, and it's easy to remember because you have G17, G18, G19, which would translate to XYZ, XYZ. G17 XY, G18 ZX, G19 YZ. So G20 is inch output as opposed to G21 would be metric. And G54 tells us that we are in work coordinate system G54 as opposed to G55, 56, 57, 58, or 59. Okay? So the second line is important for using constant surface feet, and this is what we use to limit the RPM, because theoretically the center of the turning part is not turning at all. So as it gets closer to center, the RPM is going to peak out and probably limit out the spindle, which I think is 10,000 RPM. So we always give this kind of what I would call a governor, and it says don't go over 4,000 RPM. Okay? So this line here, T101, if you remember, it's kind of like saying T0101. If you just called out T100, it would change tools to T1, but it wouldn't call out tool 1's offset. So just think of when you see that, it's reading from the farthest right. So T101 would actually be the same as saying T0101. So call up tool 1 on the tool turret and offset 1 for the tools. Remember how we set those up. And so it's always wise to put what sort of tool this is in parentheses. So the idea is that you can grab this program and set the job up with nothing but the program. So again, we're telling it G97, G0, G99, S500, M3, kind of just reiterating the safe startup. And except we're giving it that 500 RPM and turning the spindle on at M3. And then we're going to wrap it all the way down from machine home, because of this G28. That tells it machine home. I'm going to wrap it down to 2.2, which is, remember, always on the diameter. Turning is always on the diameter. So the bigger the number, the farther the tool is away from the part in X. Z0 is generally the front of the part. And then M8 is turning on the coolant. G96 S300, this will turn on the constant surface feed. So whenever you see a G96, you should also see an S value next to that, which will mean now 300 surface feet, not 300 RPM. It says keep that RPM at 300 surface feet, totally dependent on what the diameter is that the tool's turning at. G1, X minus 0.032. G1 is feed rate. It tells it to feed to X minus 0.032 at 4 thousandths per rev. So every revolution, the tool is going to advance 4 thousandths. And this will probably be the only place you see an X minus value. We have to go below center because of the radius of the tool. So that's facing the part. That's usually the first thing we want to do, because every other rapid move we can be guaranteed where the front of that stock is. So they have an example of this in the book. So I just kind of followed it. Usually if you follow the example in the book, you can't go wrong. Okay, let's talk about this G71 line. G71 is a roughing can cycle where most of the cuts are in the Z minus direction. So the P10 Q20 means read all the geometry between line 10 and line 20. And what that does, it makes a pretty fast little can cycle. So the U is how much it's going to leave in X to finish. W is how much it is going to leave in Z to finish up. And then D, 0.050, means it's going to take 50 thousandths per rev, or I'm sorry, 50 thousandths per rough cut. So that would be 25 on the side, on the radius, 50 on the diameter at 4 thousandths per rev. So our first line of geometry is this G42 X.560. So G42 is going to be turning on the tool nose compensation right, because as the tool is moving in this direction, the part is actually to the left of the tool, so it's tool nose compensation right. Okay, so it's also we also want to always use an X move to turn the tool nose compensation on. So from now on, once it reads a G42, we program the exact points on the part as opposed to having to calculate the radius of the tool. So we're going to feed into 0. And this is a lot like milling now, because you've got a G3, which is circular interpolation counterclockwise. Now you always got to remember, notice this R.7, the difference between 1.960 and 0.560 is probably 1.4. So let's double check that. Oop, I didn't want that. Yeah, so 1.960 minus 1.4 is 0.560. So if these numbers don't jive, the 0.560 and 1.960, it will throw an alarm and say radius over tolerance. Notice that the Z0 to Z minus 0.7, that's 0.7. It's the same amount. On the X, we double it. We always double our radius values on the X when we're counting the radius. So we're going to feed up to X2.1, which is off the part. I wonder if this is made out of 2-inch. Because it is one. Yeah, it must be out of 2-inch. So if you happen to find a piece of 2.5, go ahead and make it out of that and just turn it down. It'll be fine. Because we must be making this out of 2-inch. Okay. So G40, G0. Notice this N20 here. This is the last line of the geometry. So we always turn the comps off if we're using comps with a G40 in an X move off the part. All right. So before we take the tool home, we give it this G70 P10 Q20. So what this tells the machine to do is go back to this between lines 10 and 20 and read that geometry one more time, but finish the part. So it's a roughing cycle, and then with G71 would be your roughing cycle, G70 would be your finishing cycle. This is pretty basic to the example that's in the book that I gave you a put on your flash drive. So now we're going to turn the constant surface feet back off with G97 and give it a 500. Now it means RPM. So anytime you see G96 or G97, there has got to be an RPM with that. So G96, or an S value. G96, the S value would be surface feet. G97, the S value is RPM. And this is critical to use on your lathe because it just really increases your tool life, and everything's better that way. And parts run faster, things are great. So G28 is going to take X and Z0 home simultaneous. M1, we want to put a program stop between each tool. That way, if for some reason we wanted to check the tool before it ran the next one, it'd be a simple thing to do for it to just stop and wait. So once it's at home, we'll call up the next tool. And anytime you call up a T with a 202, the tool turret is going to turn. It's gonna index to the tool 202. So you want to make sure that you are clear of the spindle with the tool turret before you call up a tool. So this will be your left-hand OD turn, which is going to be actually cutting from the back side on out. So it's got to cut from the left-hand side. Oh, by the way, if you're ever wondering what a DNMG is, it's DNMG. Google knows. So that's what you're looking for. Anything shaped like that 55-degree diamond. The reason we use this tool is because it has enough clearance on the angle to cut those radiuses we want. And so, okay, this is the main reason why I just am handing you this program, basically, is because of this geometry. Again, it's too complex to take the time to trig out and all that. So tool 202, left-hand OD turn, same deal. G0, G97, G99, S500, M3 is a safe startup. So we're rapid, G0, G97 is constant surface feet off. G99 says inches per rev. Because if you told it G98, it would be trying to feed 4/1000ths of an inch per minute, which is not good because it's too slow. Worse yet is if you told it 4 inches per rev. That would be like moving beyond the capabilities of the rapid traverse probably, and likely crash into something. So yeah, this is just repeat procedure. All these lines, if you notice, they're pretty much the same. You can just copy and paste this stuff. What's important and harder to find is the actual geometry. So we're positioning in front of the part, turn on the coolant. We're turning on our constant surface feet at 300 surface feet per minute. We're telling it G18, which means any kind of radius will be cut in the ZX plane, which is going to get really important here when we start doing the live tooling, we start using different work planes. So M8, turn the coolant on. G97, so now this is constant surface feet off, which is kind of weird. So we told it G96 S300. Oh, we position it. I think we did that so that it wouldn't chatter. That's what we did. Yeah, because we left the constant surface feet off because we didn't want it to chatter. Had to turn it really slow. So G0, G54, we're still in the clear up here at X2.2, so make sure you use 2-inch material. 2 inches diameter by 12.5 inches long. Set your tool up on this first operation just to cut like 20 or 30 thousandths off the front of it. So, okay. G9 rapiding down to the Z minus 4.602, which is rapiding all the way down to here. And we're going to rapid to X2.0859. So these are Mastercam numbers at this point. And then we turned on our constant surface feed again. Kind of weird. Could be some kind of weird typo there, but I'm pretty sure this program runs. So surface feed on. Again, we're using G71 roughing. This line almost never changes, except the numbers have to be different. So you can't, if you told it P10, Q20, it would come back up and try to read this information, but you want it to read this information. So the numbers have to be different. That's a common mistake I see students make, is they don't have their line numbers matching up. And so that will cause you to have an alarm. So notice the P1 is N1, Q2 stands for N2. So U.01 is how much we're going to leave in X to finish, and W is how much we're going to leave in Z to finish, which is common to double the X because you're on the diameter. So theoretically, you're taking the same amount per side. You're only taking 5 per side, which is why you use half in W, which is incremental for Z, because you have to think UVW XYZ. Okay, so D.040, that's going to be how much it takes in each roughing pass at 4 thousandths per rev. So G99, N1 for P1, so it says to read these values for the geometry. And it's going to feed in to X1.8859 at 10 thousandths per rev, which is pretty quick. Might want to change that. Let's do that right now. Yeah, F caps lock F.004. Yeah, control save. So now we're doing that funky radius, G2. Notice we got the R 3.0003, X 1.959. Notice we're not using tool nose compensation here. And the reason is because it's going in two different directions in X. And I just thought it would just, rather than using type 2 roughing, I thought it would be easier just to let Mastercam program the exact geometry. Plus it also demonstrates that you do not have to use tool nose compensation, but these values, be sure you pick out a 30-second radius. I'm going to write that in. 30-second radius. Control save. Okay, so because that radius will reflect. Let's look at the actual drawing. It says 3 inches. Okay, anyway, so we're going to now have an extra feed move to 1.9598, Z minus 0.7. So there's a little bit of just a 0.3 of a thousandth taper there. You notice that? I don't remember if we had trouble with that for some reason or if that was just the output. But N2, that represents Q2. So again with the G70, P1, Q2, it's going to tell it to go back and read this geometry one more time, except do the exact finish operations. M9 turns the coolant off. G28 takes the machine tool home. M5 turns the spindle off. So right here we've got T808 for radial engrave, and I'm going to put that on a different video just to break things up a little bit. So we'll pick back up there.